Hello and welcome. This video is the introduction to Lesson 9.4. The goal of this video is to show you how you can use the zero product property to find solutions to an equation. And this is going to be helpful as we lead into Lesson 9.4. So first of all, what is the zero product property? Well, the zero product property states that if you take two numbers, for instance, a times b, and if you multiply them together and get 0, so the product is 0, well then it must be true that either a equals 0 or b equals 0. Because we know that in order to get 0 when you multiply two numbers, one of them, at least one of them, has to be 0. So if I give you another example, for instance, I'm taking the quantity x plus 3 times the quantity x plus 2, and if I tell you that the product is 0, the answer is 0, well then it must be true that either x plus 3 equals 0 or x plus 2 equals 0 in order for that to happen. Okay, so with that being said, understanding the zero product property, we can use it in order to come up with solutions to an equation. So here in example number 1, I'm giving you an equation. I'm saying that the product of x plus 1 and x minus 5 is equal to 0. And I want you to come up with the solutions to this equation. Well, you could plug numbers in for x and you could guess and check, or you could just solve an equation using the zero product property. And that's what I want to show you how to do. Okay. So if I take these two factors and multiply them together to get 0, it must be true that one of them would have to be 0. So either the x plus 1 would have to equal 0, or the x minus 5, that factor would have to equal 0 for the product to be 0. Okay, so what I'm going to do here is just solve both of the equations that I wrote for x. And I get a solution of -1 here. And then here, I get a solution of 5. So I'm seeing that there's two solutions for x. Well, what I want to show you in this example is how these solutions are both true. So I want to start off by checking the first one, the fact that x equals -1. So what I'm going to do is plug in -1 where you see x into the equation. So I'm going to make both x's a -1. -1 here and a -1 here. And then I just copied the rest of the equation. So let's see what happens when I plug in -1. Well, this would be 0 times, and this right here would be -6. And isn't it true that 0 times -6 would be 0? Yes, the answer of -1 checks out. So that's true. Okay, so let's just check our answer here. Let's check our answer for x equals 5. So now I'm going to plug in x equals 5 into both of the x's in the equation. So 5 plus 1 and 5 minus 5. And it says that's equal to 0. Well, let's check. Well, here I'd get 6. And 5 minus 5, I get 0. And 6 times 0 is 0. So the answer of 5 also checks out. So for this equation, there are two solutions, x equals -1 and x equals 5. And I used the zero product property to help me find the solutions. Let's try another one, number 2. Okay, so for this one, if this is true, if these two numbers multiply together to give you 0, then either one of them would have to be 0. So how can we come up with the solutions for x? Well, you can take this first 2x plus 3 and say, well, what if this quantity was equal to 0? Let's figure out the value of x. Okay, so we're going to solve. Okay, so I get x equals -3 halves, or that could be written as -1.5. Okay, so that would be a solution for x. But is that the only solution for x? No, that's just the solution for if this quantity was actually equal to 0. Okay, let's find the other solution. So now using the zero product property, this quantity could also be the one that was equal to 0. So I'm going to set that quantity, x minus 4, equal to 0. And I'm going to say, okay, if that quantity was the one that was equal to 0, what would the value of x have to be? So I can you can actually solve this in your head. I'll just write out my work. Oh, x could have been 4. Okay, so I have 2 solutions. So if you were to go back into the equation, if you were to plug in 4 in both places you see x, you're going to get a product of 0. And if you were to go back and plug in the negative 1.5 in both places that you see for x, you're also going to get a product of 0. Okay, let's try another one. Number 3. What are the solutions to this equation? Okay, well, if these two quantities are multiplied together to give you 0, one of them has to be 0. So let's start off by pulling this one down, 2y plus 1, and say, okay, if this quantity was equal to 0, what would the value of y be? So I'm just going to solve it for y. So I'm getting negative 1/2, or I could say negative 0.5. Okay, decimal or a fraction. So that's one value for y, but there's going to be another value for y because there's another factor. And so I'm going to figure out what's the other value for y. What if this factor was the one that was equal to 0? So I'm going to set that one equal to 0, and I'm going to solve for y. See, if y was a negative 14 right here, that one would be equal to 0. So I have 2 solutions for this equation. I could have negative 1/2 or negative 14. And both would work to give you a product of 0 when you multiply them together. Okay, let's try number 4. This is our last one. So here we have 7n, and we're multiplying it by 5n minus 4, and I'm saying that the product is 0. Okay, so we've got 2 factors. One of them would have to be 0 for this to be true. So I'm just going to pull down the first factor, 7n, and say, okay, what if the 7n was equal to 0? What would n have to be? What would be the value of n? N would have to be 0 divided by 7, which is 0. And wouldn't that be true? If you plugged in 0 right here, 7 times 0 would be 0, and that number would be the one that was 0. Okay, but we've got another factor. So what if this was the one that was equal to 0? So I'm going to pull it down. Say, okay, if 5n minus 4 was the one that was equal to 0, what would the value of n be? Here I'm getting n equals 4/5, or I could write it as a decimal, 0.8. Either one would be acceptable. And so we have 2 values of n for this product as well. So that's how you use the zero product property to help you solve equations. Thank you for joining me for the introduction to lesson 9.4.